Okay, so today I'm going to work through the Chapter 9 practice test. So our first set of problems are to simplify the expression. We have the negative square root of 80. Now a square root that has a negative on the outside is just going to have a negative as the answer. And when we're simplifying a square root of, oops, that's way thick. Square root of 80, we want to look at 80 and we want to break that number down. 80 is 2 times 40, and 40 is 2 times 20, and 20 is 4 times 5. So we have 2 times 2, and 4 is 2 times 2 times 5. And so remember, when we're simplifying square roots, we're looking for pairs. We have a pair of 2's and another pair of 2's. So that comes outside the square root. The negative stays out front. And so it's 2 times 2, square root of 5. And then negative 4, square root of 5 would be your answer for number 1. Number 2, when I have the square root of exponential expressions, I'm first going to look at the square root of 64. 64r squared s cubed. So I'm going to look at the square root of 64 separate from the square root of r squared, separate from s cubed. So the square root of 64 is 8. The square root of r squared is r. And the square root of s cubed, well, that's s squared times s. So I can take the square root of s squared, and I can take, that's s. And then I can't do the square root of s because I don't have a pair there. So it's s square root s. So 8r s square root s is our final answer for number 2. Number 3 is the negative square root of 243x to the 5th y times z cubed. So that's negative square root of 243. I'm just going to write it here. So 243 is, let's see, 9 times, let's see, it's 3 to the 5th power. So 9 times 27. 9 is 3 times 3. 27 is 3 times 3 times 3. So we have 2 sets of 3's. So that's negative 9. 3 times 3 is 9. And then the square root of 3 is going to stay. This little guy has to stay back underneath the square root because he doesn't have a pair to come out with. And then we have x to the 5th. That's x squared times x squared times x. If I add those exponents, don't I get x to the 5th? And the square root of x squared is x. And the square root of x squared again is also x. And then we have that lonely x over here that has to stay under the square root. So now we have x squared, because x times x is x squared, come out. And we have an x stay on the inside. And then we have the square root of y. That's the next variable. I don't have a pair there, so the y stays under the radical. And then I have the square root of z cubed, which is z times z times z. I can look at it like this, or I can look at it like z squared times z. Either way, I end up with z out front and square root z. So the z is going to go out front, and I'm going to leave a z under the radical. So negative 9x squared z square root of 3xyz. And that's my final answer for number 3. Number 4, I have the negative square root of 18 over 49. When I have the square root of a fraction, I can take the square root of the top, and I can take the square root of the bottom. The square root of the bottom is 7. Square root of 49 is 7. And then 18 is 9 times 2. 9 is 3 times 3. So that's 3 square root of 2. So I end up with negative 3 square root 2 over 7. And that could be also written as 3/7 square root 2. Either one. Most of the time it'll be written like that with a big fraction. Number 5, is the square root of 7 over 100. The square root of 7 over the square root of 100. I can't simplify the square root of 7, so that just stays square root of 7 on top. And then I have 10 in the denominator because the square root of 100 is 10. And then lastly, let's move some of this out of the way. Come over here, 6 is the square root of 100 over 25x to the 4th. So that's the square root of 100 on top, square root of 25x to the 4th in the denominator. And the square root of 100 is 10. And the square root of 25 is 5. And the square root of x to the 4th is x squared. And I can simplify this a little bit. 5 goes into 10 2 times, so I end up with 2 divided by x squared. Now remember that we have some rules that we can't have the square root in the denominator. And this isn't on this review sheet, which means it's probably not on the test, but let's just look at an extra here. If I have, say, the square root of 9 halves, well, the square root of 9 over the square root of 2 is 3 over square root 2. I can't simplify square root 2. And our rules tell us that we're not allowed to have the square root in the denominator, so we have to do what's called rationalizing it by multiplying by the denominator square root 2. And whatever I do to the bottom of the fraction, I have to do the top. So I end up with 3 square root 2 on the top. And when I multiply square roots together, I multiply the numbers underneath. So I get square root of 4. And that's 3 square root 2, and the square root of 4 is 2. And so that's how I would do that if I'm left with a square root in the denominator. So the next topic is solving using square roots. We're going to look at number 7. 16 times x minus 4 squared equals 4. Now this one says to solve using the square roots, but if I'm just told to solve this, when I see that parentheses squared, I don't want to multiply it out because that's going to make it a whole lot harder for me. What I want to do is actually get this by itself. I'm going to get the parentheses by itself. So I'm going to divide by 16. And I get x minus 4 squared equals 4 over 16. Divide them both by 4 to reduce the fraction 1/4. Now I want to get rid of the square root, the square, by taking the square root. And when I take the square root of both sides, I have plus or minus on the right side because any number that's positive squared is positive, but a negative squared is also positive. So I end up with x minus 4 equals plus or minus the square root of 1 over the square root of 4, and that is just 1/2. So I have x minus 4 equals plus or minus 1/2. And then we can add 4 to both sides. So x equals 4 plus or minus 1/2. And so that's x equals 4 plus 1/2, which is 4.5. And x equals 4 minus 1/2, which is 3.5. Number 8, 3x squared plus 26 equals 218. One of the things that tells us we can use just algebra solving and square roots is because there is only an x squared. There's no other variable in the problem. When we have an x squared and an x, we have to start by trying to factor. And then if that doesn't work, we have to go to our other tools, which is completing the square and quadratic formula. So here we have 3x squared plus 26 equals 218. And I only have an x squared and the rest are constants. So I'm going to work on getting my x squared term by itself. First, I'm going to minus the 26, and 3x squared equals 192, and then divide by 3, and x squared equals, just divide that real quick, 6 times 64. X squared equals 64. And now I'm going to take the square root. You don't want to do the square root until it is all by itself. So at this step, you need to get the x squared by itself before you try to take the square root of both sides. So we're going to square root both sides, plus or minus on the right, because when I get x equals plus or minus 8, we know that 8 squared is 64, and also that negative 8 squared is 64. So that's why we get two answers. Number 9. We'll do it over here. Negative x squared plus 9 equals 9. So we're going to subtract 9 from both sides. We get negative x squared equals 0. Divided by negative 1. There is no negative 0, so x squared equals 0. And a lot of kids get stuck on this, but really we're just going to square root both sides, and x equals 0, because 0 times 0 is 0. And there's no negative, so we don't need a plus or minus. This is the only time we get one answer, when the x squared equals 0. Every other time we should have two answers. Let's see. Okay, let's look at number 10. We have 2x plus 10 squared equals 16. So I have nothing outside my parentheses, so I need to get rid of the square by taking the square root of both sides, plus or minus the square root. So we get 2x plus 10 equals plus or minus 4. And then we're going to subtract 10 from both sides, and we get 2x equals negative 10 plus or minus 4. So that gives us two numbers. We have two equations here, really. We have 2x equals negative 10 plus 4, and we have 2x equals negative 10 minus 4. So that gives me 2x equals negative 6, and 2x equals negative 14. And then I can solve my two separate equations by dividing by 2. So x equals negative 3, and x equals negative 7. Now another way to look at this is to see x equals 2x equals negative 10 plus or minus 4 that we're going to divide by 2. And so x equals the negative 10 plus or minus 4 over 2, but we still have to actually do that, which would be negative 10 plus 4 divided by 2. That gives us the negative 6 divided by 2, which is negative 3. That answer we had already. Negative 10 minus 4 over 2 is negative 14 over 2, which is the negative 7, which we also got. Okay, let's make some space over here for number 11. There's number 10. Let's move this over. We'll do number 11 here.
I didn't log out completely. I just closed the app and it started me all over.
No, it will still show you your progress.
It will?
Yes. Okay. So now, where do I go to see your progress?
I don't know.
The analytics. Oh, that's not it. Wait, why aren't you logged out in?
I am.
No, you're not. Why doesn't it remember you?
I don't know.
And why aren't we using the app?
Because it goes into the account you made me.
Oh, well, we can log out if you'd rather. I don't know. $509? 3197008. Okay, so you have 100% on these, but you only got a 54 on that. You need to go back and keep doing this until you get it to 100. And that's how you make sure your goal is to get 100% on each of the skills so that you're getting it correct. You're doing it enough times to get it correct. So we're going to go...
I'll just do that one over again.
I know, but where can I start? There's got to be a faster way to go in and work on it more. How can we stop at 11 questions?
It's not.
Don't start crying over this shit. I'm just asking. Okay, you're not in trouble. Okay, when I tell you you need to do more, you need to do more. It's important that you know these skills for next year. So this is the one you have a 54 on. And then what about all these other ones? You didn't do these? You're just skipping around?
I thought that I did all those.
You only did these. So you want 100 little metal on each one. So go back, work on this one. Okay, finish doing that one until your SMART score is 100. Okay, so completing the square. This is something I would have done with some hands-on materials if we were in school. But what we're basically doing with completing the square is we're trying to create a perfect square trinomial so that when we factor it, it's like x plus 6 squared. So we can look at the x squared tile, and then we have 6 negative x's, and we want to try to make the best square as possible. So if I have negative x, negative x, negative x, and if I put 3 of them this way, now I'm closer to a square. Because this side is x minus 3, and this side will also be x minus 3. The problem is we're missing some stuff. We're missing all of these. And how many tiles would it take to fill this in? Well, that's 9 tiles. Negative 9. Well, no, positive 9. Positive 9 tiles. Because a negative times a negative is going to give us positive. So we have plus 9, which makes it a perfect square trinomial. And then when I factor that, I get x minus 3 squared. That's how x squared minus 6x plus 9 factors. That's a general visual idea of what you're doing with completing the square. Now the shortcut without having to make the drawing is you take the negative 6 term and we divide it in half. Why in half? Because right here we put 3 on this side and 3 on that side. A square has to have equals on both sides. So we divide it by 2 and we get negative 3. And then we square it. Why do we square it? Because down here we had negative 3 times negative 3. That's how many 1 tiles we needed to complete the square. And so that was the 9. That's where that comes from. So we take this b term, if we look at x squared plus bx plus c, we want to know what c is to complete the square. Actually, that's not right, the c there. Let's just leave that blank. I take b divided by 2 and square it. And that number, whatever that number is, goes there to make it a perfect square. All right, so these problems ask us to solve the equation by completing the square, not just complete the square. So one thing that has to be true when we're completing the square is the x squared term has to be positive 1. So whatever that coefficient is, I have to divide everything by it so that I can make that a perfect, an x squared, 1x squared. So I'm going to divide everything here. Negative x squared plus 12x minus 20 equals 0. I'm going to divide it all by negative 1. And I get x squared minus 12x plus 20 equals 0. And then my step 1 is to move the constant. Step 0, I like to call it, is divide by the coefficient a on ax squared. That's not always going to be a step. And I move the constant to the other side. So I'm going to subtract 20. So I get x squared minus 12x equals negative 20. I like to leave a space here for the number that I'm going to add. And we know that the rules of equations tell us whatever I do to one side of the equation, I have to do to the other side. So when I figure out what's going to make the left side a perfect square, when I figure that out, I'm going to add that number to both sides. So to complete the square, that's step 2. we're going to divide the b by 2, then square it. B over 2 squared. So that b is negative 12 divided by 2 and square it. That's negative 6 squared, which is positive 36. So we're going to add 36 to both sides of the equation. And I get x squared minus 12x plus 36 equals positive 16. Negative 20 plus 36 is 16. So number 3 is to factor the trinomial. I don't want to move the 16 back. It'll get me back to where I started from. So I want to factor x squared minus 12x plus 36. What two numbers multiply to 36 and add a negative 12? Well, x minus 6 squared. Notice that it's this number here that is in our factor, and that equals 16. And then 4, I'm going to solve by taking the square root. So I'm going to take the square root of both sides, and I get x minus 6 equals plus or minus 4. And then we're going to add 6 to both sides, and x equals 6 plus or minus 4. Well, I can't leave it like that because I can actually do that. 6 plus 4 equals 10, and 6 minus 4 equals 2. So my answer is 10 and 2. Okay, so let me erase that. I'm going to leave my steps here. I'm going to erase this so that we can do the next problem with the steps here. And you can always rewind it if you need to look at it more. Oh, I don't like that part. Oops. That's not good. I think this was x squared plus 4x minus 6. Let me pause. Okay, I went back and looked at the original problem. It's x squared plus 4x plus 6. So let's x squared plus 4x minus 6 equals 0. So my first step, 0, is if there's a coefficient on the x squared to divide by that. I don't have one, so I can move on to step 1, and I'm going to move the 6 to the other side. So I get x squared plus 4x. I'm going to leave a plus blank equals 6 plus blank. And now we get complete the square by dividing the b term. B is 4 here, divided by 2, and square it. 2 squared equals 4, and we're going to add that to both sides. Oh, I left that off. Really, 2b should be add that to both sides. Let's put that in our steps there. And now we're going to rewrite x squared plus 4x plus 4 equals 10. And we're going to factor x squared plus 4x plus 4. What two numbers multiply to 4 and add to 4? Positive 2 and 2. So x plus 2 squared equals 10. We'll take the square root, plus or minus the square root. And we get x plus 2 equals plus or minus the square root of 10. And we're going to subtract 2. And we get x equals negative 2 plus or minus the square root of 10. Now, some questions are going to have you leave it like this. In Algebra 2, we leave it like that because that is the most accurate answer. But if you're working in geometry and you need the length of the side of a triangle, you need the decimal. So to get the decimal, you're going to use a calculator and take the square root of, looking for my calculator here. That's not it. Well, that'll work. The square root of 10 is 3.16. So negative 2 plus or minus 3.16. So negative 2 plus 3.16 is 1.16. And negative 3 minus negative 2 minus 3.16 is negative 5.16. So I have two answers, two ways to write my answer out as well. Negative 2 plus or minus the square root of 10. and then 1.16 and 5.16, negative 5.16. It's really going to depend on the question. If it says round to the nearest hundredth, then it wants a decimal. Okay, let's look at the next one. This one, number 15, already has the constant on the side we want it. So all we have to do, we've already done step 1, it's done for us. We're going to complete the square. The b is negative 2. Divide it by 2 and square it. That's 1, negative 1 squared, which is positive 1. That's so important. Positive 1. So I have x squared minus 2x plus something equals 48 plus something. That something I'm going to add is the 1 that I got here. And then when I factor x squared minus 2x plus 1 equals 49. I'm going to factor this. That's x minus 1 squared, because negative 1 times negative 1 is positive 1, but negative 1 plus negative 1 is negative 2. So what two numbers multiply to 1 and add to negative 2? It's negative 1 and negative 1 equals 49. Then we can take the square root of both sides, plus or minus the square root. We get x minus 1 equals plus or minus the square root of 49 is 7. And we're going to add 1 to both sides, and x equals 1 plus or minus 7. So x equals 1 plus 7, which is 8, and x equals 1 minus 7, negative 6. Okay, so we have 2 more examples of completing the square. Number 16, negative x squared equals 3 minus 4x. So I'm actually going to add x squared to the other side because I like x squared to be positive. We want it to be a positive 1 anyways. So we get 0 equals, and I'm going to put these in order, x squared minus 4x plus 3. And then step 1 is to move the constant to the other side. So negative 3 equals x squared minus 4x. Now if you don't like having the x squared on the right side, then you can switch it around and make it x squared minus 4x equals negative 3. Okay, it's the same thing. Okay, so we have, I actually like that as well, minus 4x plus something equals negative 3 plus our something. How do we find what that something is? We take our b, negative 4, divide it by 2, and square it. So we get negative 2 squared, which is 4. And so we're going to add 4 to both sides, positive 4. It's always going to be a positive because we're squaring it. And then x squared minus 4x plus 4 equals 1. And that's x minus 2 squared equals 1. And x minus 2 equals, well, I'm going to take the square root of both sides, plus or minus the square root. And plus or minus, remember that the square root of 1 is 1, because 1 times 1 is 1. A lot of students leave it as square root 1. And then we're going to add 2. So x equals 2 plus or minus 1, which is 2 plus 1, which equals 3. 2 minus 1 equals 1. So x is 3 and 1. And lastly, number 17. I see this one, it's kind of a trick question because this is already a perfect square. What two numbers multiply to 49 and add to 14? 7 and 7. So we already have a perfect square, which is great. So we could just factor that x plus 7 squared equals 0. And I can take the square root, and x plus 7 equals 0. The square root of 0 is 0. Subtract 7, and x equals negative 7. Now we don't always recognize that. So if we were to move the constant to the other side, I'll show you what would happen. We get 14 divided by 2 squared is 7 squared, which is 49. Oh, and this is negative 49 on this side. So then when we add 49, and we add 49, we end up with, right where I started, x plus 7 squared equals 0. And then you solve it and get the same answer. Now the next set of problems uses the quadratic formula. The quadratic formula is actually a shortcut to completing the square. It's how we solve the problems when completing the square gets messy because of fractions. So sometimes in Algebra 1, we get a lot of answers that come out as whole numbers, which means the problem was originally factorable. But this method works for all polynomials or all quadratics, no matter what. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, and remember that our form is ax squared plus bx plus c equals 0, so this is where our a, b, and c are coming from. So if we look at number 18, my a is 1, my b is 3, and my c is 10. So we're going to plug it in. 18. X equals negative 3, negative b, plus or minus the square root of b squared, that's 3 squared, minus 4 times a, which is 1, times b, which is 10. All divided by 2 times 1, which is a. Well, actually, the x doesn't get divided by that. There. So we get negative 3 plus or minus square root of 9 minus 40 divided by 2. That's negative 3 plus or minus the square root of negative 32 divided by 2. Now, at this point in Algebra 1, we are going to say no real solution because we can't take the square root of a negative yet. But in Algebra 2, we learn about imaginary numbers that allow us to continue the problem. So for now, if I get a negative under the square root, it's no real solution. And that does mean that there are imaginary solutions, and you can talk about that with your Algebra 2 teacher in 2 years. So let's look at number 19. When I'm using quadratic formula, I want all my variables on one side, and I need it equal to 0 to identify my a, b, and c. So I'm going to add my 4x squared. So I get 4x squared plus 9x plus 18 equals 0. And my a is 4. My b is 9, and my c is 18. Now see, this is an example of where completing the square would get really messy with fractions because you'd have to divide by the 4 first, and you'd get 9/4 in the middle, and then you'd end up having to divide that by 2 and square it, and you get all these nasty fractions. So quadratic formula ends up just being easier. X equals negative 9, negative b, plus or minus the square root of 9 squared minus 4 times 4 times 18, all divided by 2 times 4. So negative 9 plus or minus the square root of 81, and 18 times 16 is 48, and 288. So again, all divided by 8. So negative 9 plus or minus the square root of 288 minus 81 is 207, negative 207 over 8. Again, I have a negative under the square root, so it's no real solution. Hopefully I gave you some problems on this worksheet that actually have solutions. Okay, let's look at these ones, 20 and 21. So for 20, a is 3, b is 36, negative 36, and c is 96. Now this one, the number is going to get pretty big, so I'll probably end up using a calculator. Negative, negative b. Okay, really important when b is negative, you have that negative, negative, because it really means the opposite of whatever b was. So negative, negative 36, plus or minus the square root of negative 36 squared, which is going to end up positive, minus 4 times 3 times 96. And that's all over 2 times 3. So let me get my calculator out. Okay, so in my calculator I've done some of these calculations. So we have x equals 36, because negative, negative makes it positive, plus or minus the square root. Negative 36 squared is 1296. And again, I just plugged 36 squared into my calculator. I didn't put the negative in because I know that a negative squared makes a positive. And a lot of times we make the mistake of putting the negative in front without putting parentheses around it, and the calculator tells us it's negative, and it's not. And then 4 times 3 times 96 is 1152 divided by 6. And that's 36 plus or minus 1296 minus 1152 is 144 divided by 6. 36 plus or minus 144, the square root of that is 12 divided by 6. And now at this point I can do the adding and subtracting because I don't have any square roots left. So I have 36 plus 12 divided by 6 and 36 minus 12 divided by 6. So that's 48 divided by 6, which is 8. And then 24 divided by 6, which is 4. So x equals 8 and 4. Okay, now let's look at number 21. I'm going to move the 19 back over. Negative 19, x squared plus 4x minus 19 equals 0. My a is 1, my b is 4, and my c is negative 19. So I have negative b, negative 4, plus or minus the square root of b squared, that's 4 squared, minus 4 times a, which is 1, times c, which is negative 19, all over 2 times a, which is 1. So negative 4 plus or minus 16. Now this is a negative and a negative, so that's going to end up being plus, and 4 times 19 is 76, and 76 plus 16 is 92, so negative 4 plus or minus the square root of 92 over 2, and 92 is 2 times 46, and that's 2 times 2 times 23, so that's 2, negative 4 plus or minus 2 square root 23 over 2. And this is how we really like to work through it in Algebra 2, so we really want you to work on being able to do this part first and then putting it into the calculator. We don't want the decimal first. So now I have, this is really negative 4 divided by 2 plus or minus 2 square root 23 divided by 2. That's what the big fraction bar means. I'm dividing them both. So when I can divide both the number in front and in front of the square root and the number in front of the plus or minus by the denominator, then I can separate it and divide it. If I only can divide one of those two numbers, then we generally just leave it. So here we get negative 2 plus or minus the square root of 23. And now if I wanted a decimal approximation, that's where I want to get it. The square root of 23 is 4.8. It's 795, so to the hundredths place that rounds up the 9, and then that 9 rounds up the, right, so this rounds up the 9, which rounds up that to 4.8. So it becomes, I'm going to work up here, negative 2 plus or minus 4.8. So negative 2 plus 4.8 is 2.8. And negative 2 minus 4.8 is negative 6.8. So my two answers are 2.8 and negative 6.8 as decimal approximations. And the exact answer is actually negative 2 plus or minus the square root of 23. And then the last thing we looked at in this chapter was the discriminant. The discriminant is the part of the square root, the part of the quadratic formula under the square root. So my discriminant is this part, b squared minus 4ac. So b squared minus 4ac is my discriminant. If this is greater than 0, that means there are two real solutions. If the discriminant equals 0, that means there is only one real solution. because the square root of 0 is 0, there's no plus or minus, so we only end up with one number. And then if it's less than 0, there's no real solutions. And we saw that in our first two examples of the quadratic formula. What was under the square root ended up negative, and so we ended up with no real solutions. And that translates to graphs. So the graphs of these quadratics, although we haven't covered it yet, are parabolas. And if the parabola crosses the x-axis twice, those are two real solutions. The solution is where the y values equal 0. And when it has only one, the vertex actually touches at one point. And when it's 0, the parabola doesn't touch the axis at all. And it could be in any of the four quadrants, but it just doesn't cross the x-axis. So that's how it translates graphically. So these problems ask you to use the discriminant to determine the number of real solutions. So we only have to do the b squared minus 4ac part. So b, this is a is 4, b is 4, and c is 7. So for number 22, I get 4 squared minus 4 times a, which is 4, times c, which is 7. So that's 16 minus 16 times 7, that's 112, which gives me negative 96. And negative is less than 0, which means there's no real solutions. Number 23. Let's get everything to one side. So we're going to add 6x and add 10. So x squared plus 6x plus 10 equals 0. So my a is 1, my b is 6, so 6 squared minus 4 times a, which is 1, times c, which is 10. So that's 36 minus 40, which is negative 4. Again, it's negative, so that means no real solutions. And then lastly, we'll add the 18. So we get, let's move stuff up here, 2x squared minus 12x plus 18 equals 0. My a is 2, my b is negative 12, and my c is positive 18. So let's see, b squared negative 12 squared minus 4 times 2 times positive 18, 4ac. That's 144 minus 18 times 8, that's 64. 6, 14, 144. 144 minus 144 is 0, which meant one real solution.